Welcome to the HeatWise tutorial video on creating wall and roof types. We'll dive into the details of wall and roof inputs and the outputs and how to interpret the outputs and how they will impact your load calculation results. So we'll start here from the walls page. You can see we have a few walls created already, but what we're going to do is create a new one from scratch. So we'll hit the create button. First thing to do is give your wall a name. So we'll just call this one new wall. And you'll see here we have our inputs, and then below we have our results. So we'll just go over the results quickly so you understand what exactly they mean and what is relevant. So first is the R value, and this is the thermal resistance, which is just how fast the heat will transfer through the wall. Then you have your wall weight. So of course some walls are going to be heavier and some are lighter. So concrete would be very heavy, whereas a wood stud wall is going to be quite a bit lighter. Your solar absorptance value, so this is to do with the color and reflectance of the wall, and the CTS vector. And the CTS vector stands for conduction time series, and this is a display of how heat will be absorbed into the wall and slowly released over time. And this is to do with the thermal mass of the wall. So heavier walls will take much longer to heat up and then release the heat back into the space or outwards to the exterior throughout the day. So it's just a matter of how slow that heat transfer can occur. But it's more to do with, rather than heat transfer, it's actually to do with the absorption of the heat. And this will impact the load calculations. So you can see here the wall weight is currently blank, and we'll just show you how this works. If we change the wall type and enter a manual wall value just for display purposes, you can see it directly shows down here, and the shape of the CTS vector has changed quite a bit. What's important to note here is that when your load calculations are running, the software will look at your R value, it will look at the absorptance, and it will look at the CTS vector when doing the calculations, but it will never actually look directly at the exterior wall weight value. So the exterior wall weight will impact this CTS vector as well, and the wall type will impact the vector and the shape of it and all these values, but the software itself will never actually be looking at this value or the wall type. It just takes those, builds the CTS vector, and then refers directly to this vector of values. So we'll just go through some of these basic inputs now. You can see we have three different categories. There's our general, our thermal resistance, and our solar absorptance. So the general is just the one input of the wall type, and of course this will not show every single wall type, so you just want to pick the one that most closely resembles your type of wall. It doesn't have to be perfect. This is just a way of estimating how the CTS vector is going to be shaped to try to estimate the behavior of the wall on warm days and how it's going to absorb and release heat. Again, it's never going to be perfect, so you just have to make your best guess. So we'll just stay with brick wall for now and move on to our second section. So thermal resistance, this is the most important section by far, particularly the R value. So the R value, of course, is the resistance of the wall, so it's how much it will resist heat transfer from exterior to interior or the other way around. You have two options for entering values. You can do it manually, or you can select the build wall option. So we'll go through both. We'll just start with manual. For entering manually, you just simply enter a manual R value and a manual wall weight. Now the R value is typically provided by architectural drawings, or is usually something that is known to within a certain degree of accuracy, whereas the weight of the wall is rarely known. So we do have a reference table here. So if we go to our recommended wall weights, you can see different types of walls have different ranges, and they're quite different from each other. For example, a curtain wall doesn't really go beyond about 16.7 pounds per square foot, whereas a brick wall only even starts at around 44 pounds per square foot, and that's because the bricks are, of course, very heavy, and they will add a lot of weight to the wall per square foot of wall area. So in this case, we might just say if we had a brick wall and we don't know the weight, we might just pick a pretty medium value without any further information. So we would just maybe round that to 83. And you'll see that the shape of the CTS vector has changed, and it just displays our output here. So again, the software is not going to be looking at that wall weight. It's not going to be looking at the wall type. It just uses those to estimate the shape of this curve, and then refers directly to this curve without going back into how it was built when those calculations are being run. And the solar absorbance value has also a manual or select by material option as well. If you open up your quick help bar on the right, you will see some instructions on what are pretty normal values. This value is almost never known directly, or sometimes it might be, but again, things can change as materials degrade over time, paint wears out. So you have to make a reasonable estimate here. Typically, it's the rule of thumb is 0.9 would be for a very dark material like a black paint or a very dark brown. 0.6 is more of a medium color like red or blue paint, and 0.3 would be used for very light colors like a white paint or something more reflective. It's very rare that you'd get below 3, and it's very rare that you'd go above 0.9. So you typically want to stay within that range. So you can just make an estimate and it will be used in the calculations, or you can select by the material, which is a good idea if you do know what the exterior of the wall will look like. So for example, if we had a brick wall and just used red bricks as our exterior facing material, then we would get a 0.63, which is a pretty medium color. If those bricks were being painted, for example, painted black, we might have a much higher value. Shingles and so on. The lightest it goes here is the white acrylic paint, which you can see is 0.26. So that's a highly reflective white paint. So it's very rare you'd get anything higher than that unless it was like literally a mirror. But the solar absorbance value is just to do with how much solar radiation is going to be absorbed into the wall versus reflected away. A higher absorbance means that the sun will have a much larger impact on the wall loads, whereas a lower value means that it's more just the outside air and the temperature of the outside air transferring into the space that's going to have that impact. So we'll show you the build wall option now. This one's more complicated, but can provide a lot of insight. So you can see it starts with 2 default layers, and that's the resistance of heat transfer between an outdoor surface and your wall and the indoor surface of the room and the wall. So those are pre-built. That can't be changed because it's impossible to not have those as long as there actually is a wall. You can add layers continuously, add as many as you like, and you can always just delete the layers if you have too many. And you'll see there's a few inputs here. We have a material category, a material type, and then in this case the thickness input is a default here, but sometimes it's not a default. So for example, if we go to an insulation material, and just with the glass fiber bat insulation, you can see we now have to enter the insulation manually. So if it was a 2x4 stud, we might have a 3.5 inch thickness, and then the R value is generated from that. Now it's important to note that when we went to our build wall option, both the R value and the exterior wall weight inputs disappeared, and they're now down here in our results section. So they're both automatically generated from this table of values. So you can see we have in this table so far, we have this insulation, and then we have just our 2 defaults, which of course have no weight associated with them, and then air gaps, which again have no weight, well, just the weight of the air really. So our exterior wall weight is extremely low, but if we added, let's say, masonry material, and we went with the high density brick layer and maybe made it 2 inch thick, now we see that our wall weight has increased significantly. So you can just do this and add as many materials as you like, and this is a good advantage for when the architect provides you the layers of the wall, and you can build the wall based on the layers provided, and then you can generate your wall weight because that value is unlikely to have been provided. If these values are provided by the architect or by whatever the source is, then we do recommend that you enter them manually rather than trying to estimate by building, because sometimes things don't work out perfectly in the building materials. These are based on available data, and sometimes different manufacturers have different values like density or R value. So if the R value of the wall is provided directly, then you should just enter that manually. So a good trick to do is, if the R value is provided for you, but the weight of the wall is not provided, then what you can do is build your wall based on the layers that are known. So for example, you could just add some drywall type materials, add your building boards, have your insulation, and use that as the baseline for your wall, and it will output some weight. And then if you know that your R value is not correct because you know that the architect is providing you with something, so let's say they were providing you an R20 wall, but without telling you the weight of it, then you could use this to build your wall, and you know it's now 26.11, and you just go to your manual entry, you hit 20, and then 26.11, that's the weight that you discovered for your wall. And now the CTS vector will be based on these two inputs, and it will be as accurate as it can be based on the available information. And it's kind of a hybrid build wall and manual entry method of entering your materials. So it's important to note that when you are building your wall, there are materials that will have pre-built or preset thickness values. So for example, a 2-inch wall gap at 2 inch is really a 2x4 stud, which is a 1.5 inch thickness gap. So for example, 1-inch stone, it's going to of course have pre-built 1-inch thickness. And if you are changing the material from something that has a pre-built thickness, so let's say we went to a limestone, it's just going to keep whatever was previously there. So it's a 1 inch. So if you do have a new thickness, you just have to make sure to change that value accordingly. So that's basically how the walls work, and what inputs matter and what they mean for your load calculations, how to build your wall selecting materials or entering manually. The other thing we're going over here is the roofs, and they work in exactly the same manner. So we just create a new roof here. You'll see very similar instructions here. And again, we have the exact same results, our R value, the weight, absorptance, and our CTS vector. And in our inputs, again, it's the exact same categories: solar absorptance, thermal resistance, and general, with our manual and our build roof options, and our manual and select by material options. And they're the exact same. Everything is the exact same, with the exception of, in the general inputs, you have different types of roofs. Of course, we're not going to have a brick roof or a curtain wall roof. Instead, we have our slope frame, wood deck, and so on. And when we build our roof by material, you'll notice that, first of all, the R values have changed because it's a horizontal surface now. And in our material categories, we have, instead of our wall materials, we have our roofing, but the rest of the materials are the exact same. So building a roof is literally the exact same as building a wall, just with those slight modifications in your options. So we won't go over them in detail here, but that's how you create a wall and interpret these results, and that's what the CTS vector is. So we'll see you in the next video.